So, simplifying radicals. If you try to find the square root of 75, so I'm going to go ahead and type in the square root of 75. If you notice, it gives you a decimal, 8.66, blah, 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 blah. So there are two main ways that I always simplify. So simplify, anytime it says simplify or give exact. So exact means do not just round this to a decimal. If it tells you to give the exact answer, then you're going to have to simplify it without just rounding it. So one of the ways, the first way to do this is to divide by perfect squares. So divide by perfect squares. And I'm going to go ahead and list out all the perfect squares so that you have them. So perfect squares. So 1 squared, 1 times 1 is 1. 2 squared, or 2 times 2 is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. I'll move that down. So those are all the perfect squares. And then you're going to take this number and divide by them to see what perfect square goes in. The reason you do that, just like yesterday, we broke the radical or the square root up into two different parts, the part that was negative and then the part that we were going to take the square root of. You're going to do kind of the same thing, except for you're breaking it up into numbers that multiply to get 75. So if you look at that, since 75 is smaller than 81, I can't even divide 75 by 81. So you're just going to start with the number that's directly smaller. So obviously 64 is not going to go in, but we'll still do it. So I'm going to take 74 and divide by 64. Oops. Well, that doesn't work. And then I'm going to keep just working backwards. The reason you work backwards is on occasion you'll have, like, if 16 goes into it, well then 4 went into it as well. So you always want to work backwards because you want the largest perfect square that goes into it. So then let's do 75 divided by 49. That doesn't work. 75 divided by 36. That doesn't work. 75 divided by 25. That works. So I can rewrite the square root of 75, the square root of 75 as the square root of 25 times 3. So I'm just rewriting it so that I have a perfect square and I have whatever was remaining. So 25 times 3 is 75. I'm going to go ahead and break it up just so that I can show the square root of 25 and the square root of 3. Since they're both in a square root, this is one of the rules with square roots, that you can just split it up, because multiplying this is going to give you the same thing. So if I do square root of 25 times 3, gives me that decimal, and the square root of 25 times the square root of, square root of 25, have to come out of that, then times the square root of 3, notice gives you the same answer. So you're able to do that based on just rules of square roots. So then we know the square root of 25, the square root of 25 is 5. So 5 times the square root of 3, that can't reduce. You can't, if you divide by 1, that's not going to simplify anything for you. You can't divide it by 4. So this is the simplified form. Okay, so that was the first way that you can do it. You kind of need to know all of your perfect squares in order to do it that way. This next way is just to use a factor tree, and it's going to give you the same answer. So if I have the square root of 75, and I'm going to write out the factors of 75. So in this case, it doesn't matter how you divide it. It doesn't matter if you start low or start small. All you have to do is take 75 and divide by a number that you know goes into it. Well, it ends in a 5, so we know 5 goes into it. So 5 times 15 goes into 75. Then you're going to break these numbers down. Does 5 have any factors other than 1 in itself? No. So then divide by 15, or divide 15. 15 has 5 times 3. 5 won't break down anymore. 3 won't break down anymore. Now, since we're finding the square root, or what number times itself gave you that information, since you have a double factor or the same factor twice, so 5, it would be 5 times 3 would give you 75. So since you have a double, you're going to pull out the pair So you're going to pull out the pair. So 5 is out, and then 3, since it was inside and it's by itself, there was no other factor like it, it just stays inside. So 5 square roots of 3. The way I like to say this, and you can think it's weird or whatever, but the way I like to say this is if you think about like going on a date. If this 3 went on the date with the couple of 5s, then it would be the third wheel. You can only take, or only the couple is going to go out. So it would be that couple right there, which is 5. So I know it's weird, but it's the easiest way for me to remember. Okay, now the whole reason we're doing this is so that we can simplify when we have a negative, because remember we were talking about imaginary numbers. So if I did the square root of negative 108, okay, I'm going to do it the first way first and divide by all of my perfect squares. So 108 divided by 100. We know that's not going to work, but again, start with the one smaller than it and then work backwards. 108 divided by 81. 108 divided by 64. 108 divided by 49. 108 divided by 36. Well, that's 3. So I can break this up. Remember, you want to get that negative away from the other stuff, so I'm going to break it up into the square root of negative 1 times that perfect square I just found, so the square root of 36 and the square root of 3, because that's what was left. Okay, now we know that the square root of 1, or negative 1, is I, because that's that rule we learned yesterday. Square root of any negative number becomes an imaginary number. And then the square root of 36 is 6. And the square root of 3 doesn't cancel, so that's what it stays as. Or reduce, not cancel, sorry. It doesn't reduce or simplify any more than that. Remember, when we rewrite this, we always want to write the number in front of the I. So it'd be 6I times the square root of 3. And that is my final answer. Okay, I'm going to go ahead and do the factor tree. Again, you guys know I don't care which way you do it as long as you get the right answer. So I'm going to do the factor tree, and then you decide which way you like better. So 108 divided by, well, it ends in an 8, so 8 will probably go into it. 4 will probably go into it. It doesn't matter. I'm just going to do 108 divided by 3. Or, sorry, 108 divided by, I said I was going to do 4 or 8. Let's do 8. Nope. 108 divided by 4. 4 and 27. So let's do 4 and 27. 4 breaks up into 2 and 2. 27 breaks up into 9 and 3. 9 breaks up into 3 and 3. So find the pairs. And you always have to find the pairs when you do the factor tree. So 2 and 2 and 3 and 3. Now, the ends of all of these is where you have to look. This 3 right here tells you, what am I trying to say? Sorry. This 3 is at the end of one of the tree branches, so it is the remaining factor. So just like we had a 3 left inside, that's that 3 that you'll see. So we know it has a negative, so we know there's going to be an I. We can pull out a pair of 2's, so you would say 2. You can pull out the 3's, so 3, and then left with the 3 still underneath the square root. These ones went out. So 2 times 3 is 6, I, and then the square root of 3. So notice it gave you the same answer. I really don't care which way you do it. In this case, usually I'm like, oh, I think this one's easier over this one, but in this case, I don't think one is easier than the other. This one you have to know how to do, or you have to know all these perfect squares. This one you just have to start dividing. It probably takes a little bit more time if you don't know the perfect squares, but it's not that big of a deal. Okay, so that is how to reduce and simplify radicals.